Hello. Welcome to my channel. In this video, we will tackle the problem 7.4 of chapter number 7 Electrodynamics of the book Introduction to Electrodynamics by David J. Griffiths. 7.4. Okay. Here in this problem, we are given that the conductivity of the material separating the cylinder and example 2, and the example 2 I have solved this one. Okay, and the link is given here in the I button, so please make sure to watch this first and then come to this video back. Okay, so this is that the conductivity is not uniform and it is position dependent for some constant K. Then find the resistance between the two cylinders. Okay, here a hint is also given that conductivity is a function of position, so equation 5 does not hold. The charge density is not zero in the resistive medium, and it does not go like 1 divided by S, but we do know that for steady current I is the same across each cylinder surface, cylindrical surface. So take it from here. Okay, now one of the simplest solution I can give you here is, first of all, we say the required thing here is the resistance. Okay, we have to find the resistance of the material that the material between the two cylinders offer to the current. Okay, so here R is unknown, but as we know that dr is equal to ds divided by sigma into A. Here you can see that this is dr, the change in the small change in the resistance is due to the small change in position. So this perfectly define our condition. Okay, and we say this is equation 1, and we have also given that the conductivity is position dependent is equal to K divided by S for some constant K. Okay, this is also given. Now we will put this here, and the area is also given that area of a cylinder is 2 pi S into L. Let's say this is equation 3 and this is equation 2. Okay, let's say this is equation 2. So we put equation 2 and 3 in 1, so we get dr is equal to ds divided by K by S, and this will become 2 pi S into L, where this is the area and this is conductivity. So this S and S will cancel each other, so we only left with ds divided by 2 pi K into L. Okay, now we integrate on both sides. Okay, here first of all we write this ds divided by 2 pi K into L. Okay, by integrating on both side and the side is from A to B, we get that R equals to, these terms are constant, so this will come outside of the integral, and integral is from A to B and ds. Okay, now this integral is equal to 1 divided by 2 pi K into L, and this integral is S, and this is from A to B. Okay, and this will goes like 1 divided by 2 pi K into L, and this will become upper limit minus lower limit, and upper limit is B minus lower limit is A. Okay, so the resultant resistance is B minus A divided by 2 pi K into L. So equation 3 represents the resistance that the material of conductivity sigma into S offers to current. Okay, if you like the video, please don't forget to subscribe the channel and comment on the video, and like the video. Okay, and if you have any question, you can ask me in the comment box. I will respond as soon as possible. Thanks for watching.